Hello, Tim Graves here again with another video in our sequence of how to do fun things with Helidon. So what we've done so far in the previous videos, we've created a microservice. In fact, we've created two. We've REST enabled them. We've put security on there. We've set them up so that they can read configuration data. We've seen how to manage configuration data and configuration data files, and also how to talk to a database and get the context from our requests. Of course, that's great, but what happens if we want our two services to talk together? So in this scenario, there's a whole bunch of history here. In the really bad old days, so to speak, what you would have done is you would literally have created your own code based on the URL class, maybe an HTTP connection. You'd have converted all of the body contents into the right format, set that up, created an output stream, established the connection, and done everything like that. Absolute pain to write. It's probably a couple hundred lines if you're doing that on a decent sized service. Now, over time, this got a bit easier. Spring Boot, for example, introduced the idea of a REST template and a REST template builder that allows you to set up a fair amount of stuff, but you still had to work out what class to call and what URL to do. And fundamentally, that meant you were changing your code. So what we want to do is we want to find a way of doing this where we minimize the changes to the code as much as possible. And fortunately for us, Eclipse Microprofile, which is what Helidon MP is based on, has come up with the idea called a REST client. Now, a REST client is basically an automated process for taking an annotated interface and creating an instance of the class or instance of that interface dynamically behind the scenes that does all of the work you need it to do. So it does all of the work of setting up the connections and stuff like that. From a development perspective, you just program as if it was the interface. Now, that's great, makes life a lot easier. There is a question of where does that interface physically live? And here we end up with one of those interesting architectural problems. In a Java programming world, of course, what you would like to do is you would like to have that interface in maybe a common package or a common module that is shared and is accessible from the client. So we know the client knows exactly what is being accessed, and the server would also implement this. So we can ensure that the client and the server have a common set of code to work with. And Java, you would literally create the interface once and share it between both of those sets of code. The microservices world treats things a little bit differently. So that in the microservices world, the basic architectural design model is you keep both sides completely separate so that what is effectively the contract between the two is not a programming interface, but basically it's the over-the-wire protocol, what it looks like, what data formats and the fields are, that are actually sent as the body of a request. Now, as a Java programmer, I kind of dislike this. As a microservices guy, I kind of like it. There are other reasons why you might want to do this. For example, you may be talking to a microservice that's not Java-based, and therefore there isn't an interface available to start with, so you have to create your own. Which approach you take is fundamentally going to be down to how you want to structure things. My personal opinion is if I have existing code that it is set up in a sort of client API and a server API model using a shared interface, I would probably stick to that, even if I then split that client and server into separate microservices. If I was creating something new, I'd probably set them up as separate. You have to work the details out on that based on your environment. So let's have a look at how this would work. Well, obviously, one of the joys of using an interface is it's an interface, right? So what we can do is here, Stock Manager is actually an interface, right? And if we go and look at this, the Stock Manager REST client, you will see a Stock Manager interface is effectively defining a set of method calls, and there are annotations on those to say what that would call. So you can see here we have a call which does a get call, and it produces JSON, and that JSON contains a collection of item details, which is get all stock levels. Now, for this particular piece of code, I have gone through I am separating these into two separate distinct sets of code. So if we have a look at the stock resource, the method that we're matching this onto is actually called list all stock, but it does return a set of item details. So first thing to see here, the method in your interface doesn't have to match the method name from a coding perspective, because this is not a shared interface. Now, obviously, the stock resource itself could have its own definition of what that interface looks like. So first of all, let's have a look at our interface, and we're going to put a couple of annotations on here that will make this eligible to be used within the REST client builder code. So we're going to make this application scoped. Okay. So as you may recall from earlier, that means that there is only going to be a single instance of that piece of code. Okay, so the next thing that we're going to do is we're going to say where to get the configuration from, and to effectively tell the Helidon code that this piece of code is something that is eligible for this dynamic creation of a underlying REST type implementation. So register REST client is just the annotation that says, yeah, this is something that can be used as the basis of a REST client. The config key specifies what that configuration, or what any configuration relating to this should be stored under in the configuration. We'll have a look at that configuration service in a moment. But effectively, this just makes it a little bit easier to set up your configuration files. You don't have to have it. If you don't have it, it'll use the class name fully qualified. So now we have told Helidon, this is something that you can dynamically create a REST client from. Now, how would we use this? Well, we would use it the same as any other interface. Now, we obviously have to do a little bit more than just say this is an instance of an interface, so we need to inject it. Okay, and we will also need to tell our code that in this case, what I want you to inject is a specifically dynamically created implementation of that interface, which is a REST client. Okay, so that will tell our code that what you need to do is create a REST client instance. And what I'm going to do is I'm just going to remove this stock manager equals null. Strictly speaking, I don't need to do that because our code won't come into play in terms of dynamically creating a client until the storefront resource instance has been instantiated. So the injection happens after the class is instantiated, so it would have overridden that null. Okay, so nice and simple. We have done that. What does that look like in terms of our configuration? Let's have a look. Where do we store this? So this is stored in the microprofile config file. In this particular case, obviously this is something that you could override further down. And what I have done here, you can see that I have set up things under the stock manager class. So basically, stock manager class MP REST. This is the URL I want you to go to, and this is a couple of connection timeout settings. You can see a little bit further up as an example of what would happen if I hadn't specified a config key. This is for another REST service that is being used, and we would have had to put the fully qualified class in there. Which one you choose is up to you. I personally think that having a shorter name there is easier, but if you've got lots of conflicting names in similar class files and packages, then you may want to split this apart. That's up to you. Okay, so let's make sure we've saved all of those, and let's go and run this. So we run our server code. So actually the server database is already running. So let's go and make a REST request to our service. Oops. So there we go. Oops, bit of a problem here. We've got a failed dependency. Well, you may recall earlier on, we said any problems when you're talking to the backend database service for that particular method gets called the failure mode or the failure method. And that effectively converts that into a 424, which says, I can't talk to the backend service. Now, in this particular case, that's not telling us an awful lot of information. Perhaps we might have wanted to put the other type of failure processing where we can get a bit more information out of it. But we do have the stack trace in our class down here. So let's go and have a look at what we've got here. And we've got a 401. Now, for the HTTP geeks amongst you, 401 basically means you didn't provide the authentication information. But how come? We did provide the authentication information in the request. Well, here's where we need to start thinking about the fact that this is now two completely separate services running in two separate Java virtual machines. Right? The storefront service received the request and it did have a valid username and password. However, the backend service, the stock manager, obviously didn't. Why is this? Well, basically, Helidon will not automatically transmit authentication information it receives when it is making a backend service call. There are a number of reasons for this. It may be that you want to override the authentication information and put different information in there. It may well be that the backend service you're calling doesn't require authentication and you don't want to propagate credentials when that's not needed. So what we need to do is we need to tell Helidon to do this. Now, we could write a bunch of code to do this, but it's a lot easier if we just go and edit in our security configuration files. So let me just go and find the one I had prepared earlier. Is all good chef environments. So let's have a look where we're going to do this. We're going to do this in the security front. So what I've done is I have added this to our HTTP environment, so our HTTP settings. And effectively what we're doing is this is the outbound setting, just giving it a name. And we're saying that this is applicable to any host. So any host that receives this, the security credentials will be automatically propagated. Now, we could restrict this if we wanted to. We could also override this, specifying a different set of credentials to be used. This is one of the joys of using configuration files for this kind of thing. So now, if we go and run our microservice, or our storefront microservice, okay, so there's the service itself running. I go and make the request. Now what will happen is that request will automatically have its credentials propagated for us. And as you can see, we have correctly got the result. So this is really nice, and it obviously works well with Helidon. But one of the things that people look at quite often is they want to take a little piece of code, maybe from something running in WebLogic, and split that apart. So can they do something similar to this when the calling code itself is not Helidon based? And the answer is absolutely yes. What you can do is you can create your interface. You may well even already have an interface. As you saw, put the appropriate annotations on that interface so that it knows where it's going, what the URL is, and stuff like that. And you need to make sure that you have the appropriate client libraries available. Now, what you can then do is it's a little bit more of a manual process, but basically you can create a REST client builder that will take that interface and effectively it does the underlying creation for you. So you end up with a piece of code that you can then use further on in your code, programming to the interface as if it was the object. So this is a really easy way to separate out existing code, especially if you already have an interface. So what we've just seen here is how easy it is using Helidon to create a mechanism to communicate between two services. There's obviously a lot more to this in terms of identifying how you would want that data propagation to happen, maybe how you want to handle exceptions and so on. Go and have a look at the Helidon documentation on that. There's some really good examples in there. And that is basically all we have to cover for this particular piece of code. Or this particular video. What we're going to be doing next is we're going to be looking at some of the additional features that you might want to consider using with your Helidon-based services if you're going to be deploying into more of a production type environment. So that will include things like how you generate tracing information to understand what's happening as a request propagates across multiple microservices, and also how to have Helidon generate specific pieces of information that are really useful when you're running in a cloud-native environment, especially within Kubernetes. So thank you for your time. If you want to see the source code to this, or if you want to do the lab that this set of videos is based on, the instructions on how to get access to that is coming up just now. What you've just seen is based on a lab, which goes through effectively using Helidon to create microservices from a monolith piece of code. This lab is available to anybody on the internet. It's originally written to work in the Oracle Cloud, but you can take the source code from the Git repository and run it in your own environment. You can use a MySQL database or other databases if you want to. So what I'm going to do now is quickly show you how to get to the lab. That will include links to where you can download the original template source code and obviously the content of the lab itself. So in a web browser, if you go to bit.ly/go live labs, okay, and that will take you to the Oracle Live Labs starting page. Then search for using Helidon to create microservices from a monolith. Now that's going to return two lab options. The overall sequence of videos is based on the extended lab version, but if you don't want to do the extended stuff, you can just focus on the shorter version. You basically just click the launch button, and then if you want to run it on an Oracle trial, you can register for free trial environment. If you already have a free trial environment, you can then look at running it within that environment. You just basically click on that. You can then have access to the web page. Effectively, what you need to do, follow the instructions under Getting Started and set up your tenancy and set up for the Helidon Labs to get this working in the Oracle Cloud environment. Now, if you don't want to use the Oracle Cloud environment, then there are instructions on how to download the source code using in the setup for Helidon Labs section. You'll obviously need to make sure that you've got Java 11 on your laptop. You're going to need to make sure that you've got a suitable IDE and so on. If you want to use a database other than the Oracle database, you can do that, but you'll need to configure the database files so that you can ensure that it will work on the local database, and that's basically through the JDBC and JPA, JTA settings in the meta-inf folder. So thank you for that. Hopefully you will enjoy playing with that, and good luck.